Hey, this is Joe Rataski here for fourth grade exploring addition and subtraction with decimals. This is our special hurricane evacuation episode, so I'm all by myself today. So I would like you to, in just a second, you're going to pause and complete this task. You can do this by yourself or with your team or partner. Just look at all these images on the screen and kind of think about what do you notice and what do you wonder. Think about which groups, which models or tools are groupable and which are proportional. And what would this mean in terms of working with decimals? So go ahead and pause the video right here and work on that task. All right, welcome back. We're going to come back to these questions towards the end of this video. All right, let's check out our progression of decimals with the best. We'll see in gray there, you have second and third grade, where students are exploring how to add and subtract whole numbers. Then we get into blue and the subject of this video. So now we're in fourth grade. Students were introduced to decimal notation and how that might relate to fractions with denominators of 10 and 100. And now currently students are going to explore the addition and subtraction with those decimal multi-digit numbers. And in fifth grade, students will move into the thousandths place, and notice fifth grade says that is where students are using a standard algorithm with procedural fluency. So in fourth grade, we are really working in this fluency stage 1 of exploration. So thinking of that stage, that is where students are using manipulatives, visual models, they're having good discussions, they're using estimation, they should always be doing that, and drawings to really understand, to explore what that means when we're adding and subtracting with decimals. We're not jumping into any kind of a standard algorithm in fourth grade. That is the goal of fifth grade. All right, let's look at some of those tools, some of those models we could use. Base 10 blocks are fantastic. You probably were already using them with whole number place value. It should be something that students are used to. And we're really looking at that 10 times as much, 10 times less than, 10 times greater, 10 times less connection in our base 10 system. Also, students use these to regroup our base 10s when they're working with whole numbers. So when I would add my ones, if I had more than 10 ones, I could group them together and make a 10. And I can physically do that with these base 10 blocks. I can make a group of 10, trade it for a 10. I can make a group of 10 10s, trade that for one of our 100s. Another thing that we want kids always exploring is that in our base 10, these base 10 blocks, they can represent any of the place values. If we want to now start using them with decimals, we have to figure out which of these would represent the whole. So maybe if one of those longs represented the whole, what would the place values be of some of these other pieces? So if that represents 1, we see our flat now could be 10, our large cube could be 100, and our small cube would be 1/10 because it's 1/10 of what our 1 now represents. But we can change that. What if our flat represents one whole? How is that going to change the place values of these other blocks? Well, everything's going to kind of shift a little bit, right? Now our big cube is now worth 10 because 10 flats would make the big cube. And if we work backwards, if we take our flat and split it or divide it into tenths, each of those longs are now going to be 1/10. And then we can break those into 10 smaller cubes, or see that it takes 100 of those small cubes to represent the flat. So those are now worth 1/100th. And it's great then for kids to use these on a mat. We can say, okay, in this case, we're going to have our 10s, our 1s, our 10ths, our 100ths. We can group these on the mat. We can physically move them around. And all the while, we can record what's happening. So we're going to look at what that might look like with adding with our actual physical base 10 blocks, which is our nice concrete model that we want to start with. So kids are getting used to, they're connecting this to what they did with whole numbers. They're able to move, touch, manipulate, all kinds of things are going on in their brains. Synapses are firing. They're understanding what this looks like. And we're also then able to represent, oh, look, in 13 and 6/10, we had 3 digits, but the place values that they're in are different, right? That 1 is now in our 10, the 6 is in our tenths. Where in 2 and 54 hundredths, those were 3 digits, but those place values are very different. We can now, when we're adding, look at that regrouping, that they hopefully have that understanding. We did this with whole numbers. It's the same thing with decimals. And now we, of course, want to record. So we have 110. We now have 6 of our ones. We have 1/10, and we have 4 hundredths. So that would give us our sum. That helps students, especially those who are struggling. If I just wrote all those digits together on top of each other, I'm losing my place values. They're not consistent. A lot of kids struggle with losing where that decimal point goes. This is going to help them to understand why we need to line up the decimal point, right? This is going to work with subtraction too, especially when we have to regroup. And look, we're regrouping across a 0. All kinds of mistakes can happen there. So we definitely want kids to show why what they're recording is happening when we work across a 0. I have to take one of those tenths and trade it for 10 hundredths. Now I can take away 7 hundredths. I can take away 0 tenths. I don't have to do anything. And now I can take away one of my ones. And I see what I'm left with 3 ones, 2 tenths, and 4 hundredths, or 3 and 24 hundredths. It's very important kids have a lot of experience with this. Kids can then move on to drawing their base 10 blocks. This is the same problem, but we're just going to do it with drawings over base 10 blocks. I can still represent that same kind of regrouping. So I can think of this, even breaking it apart, as 4 ones, 3 tenths, 1 hundredth. I have enough to take away 1. I don't have enough hundredths to subtract 7 hundredths. So I'm going to do that same thing I did with the base 10 blocks. So perhaps one student could have the base 10 blocks out where another student next to them is recording, so they can see that connection between the concrete and the representation they're drawing. But that same kind of process is kind of happening. Oh, I now have 11 hundredths. I now have 2 tenths. Think about how what they're recording up there of their drawings is going to help them in 5th grade when they're going to be using some kind of an algorithm. But for right now in 4th grade, whatever they can use, whatever models, whatever strategies they can use to get the correct sum or difference, that's what the goal of 4th grade is, that exploration. Next, moving on, we can use some of those 100 grids. These basically just look like paper versions of some of our base 10 blocks, don't they? But with our grid, a square representing 1, the lines broken up into 10 representing tenths, and then 100 little squares representing our hundredths. We can look at doing partial sums. Here's 4 tenths written as a decimal and even a fraction, just as kind of a reminder. Decimals are a shortcut for those fractions. 36 hundredths. So when we're adding those together, those are 2 different place values that we're going to add together. But I can take 4 of my tenths and color them in as 40 hundredths. And now I have my total all represented in one place on the grid. Have students explore how this is different than if we were adding just tenths and hundredths. They're different place values. But we can rewrite those tenths as hundredths. How is this different here? Same digits, right? But that 4 is now in a different place. That 4 now represents 4 hundredths instead of 4 tenths before. And we still have the same 36 hundredths. When we put those together, we're now going to have 40 of our hundredths. So have kids explore moving those same digits around and notice what that difference is. That's where a lot of kids make mistakes. And we can even transfer that over 40 hundredths. Oh, that's the same as 4 tenths. Place value discs, another great concrete material students can work with. But notice the difference with these is that all the discs are the same size, no matter what their place value is. The 1 disc is the same size as the 1/10th disc, is the same size as the 100th disc. And if I had my millionth disc on here, that would be the same size. So we don't want to start with place value discs. We want to make sure kids start with the base 10 blocks so that they understand that base 10 system of regrouping. So this is the same addition problem we showed before. The place value discs are just a little bit easier to use because they're all the same. We can still show that we can make 10 and regroup them and put them together. And we're still going to wind up with the same sum. Why do we want kids using those place value discs? Because they can then draw pictures with their place value discs as well. So they're kind of, each model is getting a little bit faster of what we can use. This is that same problem we did before. I can trade a tenth for 10 hundredths. It doesn't mean that they're proportional, that those 10 little circles are going to equal one of these bigger circles. They're not. They're all exactly the same. It's just a loose representation of something that we can use to move around in our place value system. But still, we want to encourage students to use these. They can move them around. They can memorize or start to understand and memorize what's happening, and then use their drawings as well. And of course, all the time, we're making sure we're recording what's happening. Here's one that might be really difficult as we're regrouping across a zero. So students can make sense of what's happening here. Oh, I'm taking a 1. I have to trade it for 10 tenths. And then I can take one of those tenths and trade it for 10 100ths. And that's why we end up actually having a 9 in the tenths place. Because look, I only had 9 of those tenths. And now I can go ahead, take away my 7 hundredths, my 2 tenths, my 1 1, and I end up with 1 and 77 hundredths. We also want to connect back to strategies that kids use with whole numbers. Think about this, 1002 minus 997. I know a lot of you are like, oh, there's so many zeros, there's so many crossing off and regrouping. They're going to have a bad time with that, right? But let's think back. Let's even use a number line as a good place. Think of our benchmark 1,000. 997 and 1002 are really close together. A lot of kids, if they would stop, estimate, think, reason, they could just count up. So I know from 1000 to 1002, it's just a jump of 2. From 997 to 1000, it's just a jump of 3. And altogether, that's just a jump of 5. So the difference is 5. All of that can really be done in your head. Now, that same kind of strategy, numbers that are really close, we can just use that counting up. Think about this. How is this similar? How is it different? We know it's a decimal, but aren't those values pretty close? 1 and 2 hundredths, 97 hundredths. Let's see what that looks like on the number line. First, we have our benchmark 1. 1 and 2 hundredths. And then on the other side, 97 hundredths. Think of those same jumps. To get from 1 to 2 hundredths is just a jump of 2 hundredths. 97 hundredths to a whole, that's only 3 hundredths. So really, these are only 5 hundredths apart. I can use that same counting up strategy. And really, any numbers, I can use this counting up strategy. Kids are often a lot more comfortable and often a lot more efficient at adding instead of subtracting. Why don't we take advantage of that? Let's use adding to subtract. It's just the opposite. They can break it up in different ways. Let's count up here first. 2 tenths or 20 hundredths. I can count up 5 hundredths and get to 70 hundredths or 7 tenths. And then I know that's just a jump of 3 tenths or 30 hundredths. Put all those together, and what do we get? Pretty simple, 55 hundredths. I can do that so much quicker, so much easier, especially if I can just represent that on a number line. Eventually, I could probably count up like that in my head versus having to do a whole bunch of crossing out. And remember, in 4th grade, we're not trying to get to the algorithm. Any kind of abstract recording that students are coming up with too, just like they did with whole numbers. Break it up. Use their place value to break these numbers up when they're adding. So I can break up by place value. Now add those back together. I get 10. I get 7 ones. I get 1 and 5 tenths, or 15 tenths, and I have 6 hundredths. Then combine them now together. All my whole numbers there are 18. Plus I have that 5 tenths, and I have my 6 hundredths. Same thing can kind of happen with subtraction. I can use that counting up that I was doing on my number line. 1 and 27 hundredths. Okay, let's just get to a next benchmark. 1 and 30 hundredths. How much more do we need to then get to our next whole number? 70 hundredths to get to 2 wholes. And now I could count up 1. I could count up 1 and 4 tenths. It doesn't really matter. I'm getting to my number. Different kids are going to have different approaches to it. Now let's just look at our partial sums and add them all together to find the difference. 3 hundredths. I counted up 70 hundredths. Then I counted up 1 and 4 hundredths. For a total, I would need to count up 1 and 77 hundredths to get to 3 and 4 tenths. So that is our difference. Build on these strategies that kids have from working with whole numbers. So back to our models. We said some of these manipulatives, we might have heard us talking about this, right? They demonstrate that base 10 relationship, and they're also groupable and proportional. That would be any of these, our base 10 blocks and our 100 mats. They are proportional to each other. As the place value increases, we need 10 of each of those to get to that next place value. I need 10 small cubes to make a long, 10 longs to make a flat. So they are proportional and they are groupable. I can make a group of 10 and trade those in. We have to start with those models first. Then we can move on to maybe using our place value mat, using our place value discs. Those don't have a base 10 relationship. They're not proportional, but I can group them. I know I can take 10 ones and put those discs together and trade it in for 10 ones for a 10. Or take 1 and trade it in for 10 tenths. I can do that. But what about just money? The concept of money definitely lends itself as a context for decimals, but using coins, using bills, they're not proportional. A dime is worth more than a quarter or worth more than a penny, but it's smaller. So that can often be very confusing, especially if we start there. Eventually, you can go to it once students have that full understanding of place value with decimals, but it's not a place to start. Money is not groupable. It's not proportional. So possible misconceptions we know kids maybe struggle with that place value, right? But think about all these models that we did. You can't just tell kids to line up the decimal point. Working with base 10 blocks, they can see that they have to do that. Working with the place value discs on the mat, they have to see. We need to add tenths to tenths, ones to ones, hundredths to hundredths, just like they did with whole numbers. So we want kids having that experience with those. We want them bringing it back and connecting to what they did with whole numbers. And don't forget, before you start adding or subtracting, make an estimate. Because if you know your estimate should be around like 3 and something and you end up with 30 something, well, something went wrong, right? So make sure, just like we do with whole numbers, we want to estimate, determine reasonableness first. This is a great context. Our exploration here is really going to bring students through all the concrete, base 10 blocks, place value discs, to the representational, their drawings of those, and into the abstract, where they're using some of those different strategies of counting up to subtract, breaking numbers apart. All right, I hope you found all this information very valuable, and I think your students will enjoy exploring what it's like to add and subtract with decimals.